Hi, we are doing Chapter 3, Section 3, Ocean Water Chemistry. Today we're going to talk about how salty is ocean water, how do the temperature and gas content of the ocean water vary, and how do conditions in the ocean change with depth. If you've ever swallowed some water while you were swimming in the ocean, you know that the ocean is salty. Why? According to an old Swedish legend, it's all because of a magic mill. This mill could grind out anything its owner wanted, such as herring, porridge, or even gold. A greedy sea captain once stole the mill and took it away on his ship, but without finding out how to use it. He asked the mill to grind some salt, but then could not stop it. The mill ground more and more salt until the captain's ship sank from its weight. According to the tale, the mill is still at the bottom of the sea, grinding out salts. The salty ocean. Probably no one ever took this legend seriously, even when it was first told. The scientific explanation for the ocean's saltiness begins with the early stages of Earth's history, when the ocean covered much of the surface of the planet. Undersea volcanoes erupted, spewing chemicals into the water. Gradually, the lava from these volcanic eruptions built up areas of land. Rain fell over the bare land, washing more chemicals from the rocks into the ocean. Over time, these dissolved substances built up the levels present in the ocean today. Salinity. Just how salty is the ocean? If you boiled a kilogram of ocean water in a pot until all the water was gone, there would be about 35 grams of salt left in the pot. On average, 1 kilogram of ocean water contains about 35 grams of salt. That is 35 parts per thousand. The total amount of dissolved salt is a sample of water is the salinity of that sample. The substance you know as table salt, sodium chloride, is the salt present in the greatest amount in the ocean water. When sodium chloride dissolves in water, it separates into sodium and chloride particles called ions. Other salts, such as magnesium chloride, form form ions in the water to do the same thing. Together, chloride and sodium make up almost 86% of the ions dissolved in ocean water. Ocean water also contains small amounts of about a dozen other ions, including magnesium and calcium and other substances that organisms need, such as nitrogen and phosphorus. Okay, here's the composition of the ocean water. Ocean water contains many different dissolved salts. When salts dissolve, they separate into particles called ions. So here we have, you can see chloride, sodium, sulfate, magnesium, calcium, potassium, and other. And you can see the majority is chloride and sodium ions in the ocean water. Salt and density. These people are relaxing with the paper while floating in the water. The Dead Sea between Israel and Jordan is so salty that people float easily on its surface. Variations in salinity. In most of the ocean, the salinity is between 35 and 37 parts per thousand. But near the ocean surface, rain, snow, and melting ice add fresh water, lowering the salinity. Salinity is also lower near the amounts of large rivers such as the Amazon or Mississippi. These rivers empty great amounts of fresh water into the ocean. Evaporation, on the other hand, increases salinity since the salt left behind as the water evaporates. For example, the Red Sea, where the climate is hot and dry, the salinity can be as high as 41 parts per thousand. Salinity can also be higher near the poles. As the surface water freezes into ice, the salt is left behind in the remaining water. Okay, effects of salinity. Salinity affects several properties of ocean water. For instance, ocean water does not freeze until the temperature drops to about a negative 1.9 degrees Celsius. The salt acts as a kind of antifreeze by interfering with the formation of ice crystals. Salt water also has a higher density than fresh water. That means that the mass of 1 liter of salt water is greater than the mass of 1 liter of fresh water. Because its density is greater, seawater has greater buoyancy. It lifts or buoys up less dense objects floating in it. This is why an egg floats higher in saltwater than in freshwater, and why the people in Figure 14 float so effortlessly in the Dead Sea. Okay, here's some more math practice on calculating density. We did that earlier last week. Ocean properties. In New England, the news report on New Year's Day often features the shivering members of a polar bear club taking a dip in the icy Atlantic Ocean. Yet on the same day, people enjoy the warm waters of Puerto Rico Beach. Like temperatures on land, temperatures on the surface of the ocean vary with location and the season. Gases in the ocean water vary as well. Temperatures in ocean water. Why do surface temperatures of the ocean vary from place to place? The broad surface of the ocean absorbs energy from the sun. Near the equator, surface ocean temperatures often reach 25 degrees Celsius, about room temperature. The temperature drops as you travel away from the equator. Because warm water is less dense than cold water, warm water focuses only a thin layer on the ocean surface. Generally, the deeper you descend into the ocean, the colder and denser the water becomes. When the water temperature is lower, the water molecules stay closer together than at higher temperatures. So as a sample of cold water has more water molecules than a sample of warm water of the same volume, the sample of cold water is denser. Gases in ocean water. Just as land organisms use gases found in the air, ocean organisms use gases found in the ocean water. Two gases that ocean organisms use are carbon dioxide and oxygen. Carbon dioxide is about 60 times as plentiful in the oceans as in the air. Algae need carbon dioxide for photosynthesis. Animals such as corals also use carbon dioxide, which produces the carbon to build their hard skeletons. Unlike carbon dioxide, oxygen is scarcer in seawater than in air. Oxygen is more plentiful in seawater near the surface. Oxygen in seawater comes from the air and from algae in the ocean. As a product of photosynthesis, the amount of oxygen in seawater is affected by the water temperature. The cold water in the polar regions contain more oxygen than warm tropical waters, but there is still enough oxygen in the tropical seawaters to support a variety of organisms. Okay, so we have a water column here. Okay, so here's the conditions as you descend into the ocean. We have the surface zone. It extends from the surface to about 200 meters, and this is the average temperature worldwide. Is about 17.5 degrees C. Okay, so then we have a transition zone. It extends from the bottom of the surface zone to about 1 kilometer. The temperature rapidly drops to 4 degrees C. During this area, color and light penetrate the surface of the ocean. It appears first yellowish, then bluish green as the water absorbs the red light. No light reaches beyond 200 meters. So notice that the surface zone is 200 meters deep. Color and light does not reach beyond that. Okay. Temperature near the surface temperature is affected by weather above. In the transition zone, the temperature drops rapidly. In the deep zone, the water is extremely cold. So we're here at the deep zone now. And it extends from 1 kilometer to ocean floor, and its temperature is about 3.5 degrees Celsius. Okay, salinity. Rainfall decreases salinity near the surface, while evaporation increases salinity in warm, dry areas. Below the surface zone, salinity remains fairly constant throughout the water column. Density. The density of seawater depends on temperature and salinity. The ocean is generally less dense in the surface area where it is warmest. However, higher salinity also increases density. The more dense water is found in the cold, deep zone. So in the cold, deep zone here, it's also more dense. Pressure increases at the rate of 10 times the air pressure at sea level per 100 meters of depth. So the pressure increases as you get deeper in the ocean. Okay, changes with depth. If you could descend from the ocean surface to the ocean floor, you would pass through a vertical section of the ocean referred to as the water column, and figure 16 on the previous page shows some of the dramatic changes you would observe. So we've already talked about that. Decreasing temperature. As you descend through the ocean, the water temperature decreases. There are 3 temperature zones in the water column. The surface zone is the warmest. It typically extends from the surface to about 100 to 500 meters. The transition zone extends from the bottom of the surface zone to about 1 kilometer. Temperatures drop very quickly as you descend through the transition zone to about 4 degrees Celsius. Below the transition zone is the deep zone. Average temperatures there are 3.5 degrees Celsius in most of the ocean. Increasing pressure. Water pressure is the force exerted by the weight of water. Pressure increases continuously with the depth in the ocean. Because of the high pressure in the deep ocean, divers can descend safely only about 40 meters. To observe the deep ocean, scientists must use submersible, a underwater vehicle built of materials that resist pressure. All right, that's the end of our lesson today. Your homework is to do section 3 assessment. I will see you again tomorrow.